Okay, here are the notes for the United States Clean Air Act. Okay, so United States Clean Air Act, or the U.S. Clean Air Act, that's the notes topic for today. Well, first of all, I want to define what an act is. An act is a federal law created by Congress. Okay, so whenever you see act, the Clean Air Act, the CARES Act, okay, any act is a federal law created by Congress, okay? So the Clean Air Act is one of those laws, and we're going to talk about that in these notes, okay? So first off, in the Clean Air Act, it was created in 1963. So back in the late 50s, early 60s, air quality across our country, especially in big cities, was horrendous, super bad, very unhealthy, toxic air. And so this law was created in 1963, and its purpose, it had a goal. The goal was to control air pollution on a national level. To control air pollution on a national level. Let's make that bigger for you guys. Okay, so we wanted to clean air across the country, make it a national goal instead of local control. It is administered and enforced by the Environmental Protection Agency, which is the EPA, okay, with state and local government help. Okay, so when the EPA finds somebody is breaking this law, they will use local authorities to help them make arrests or fines or things like that, okay? It includes regulatory controls, regulatory controls for several things. We're gonna go through a few, okay? So stationary and mobile sources of air pollution that currently produce pollutants. Okay, so stationary means it's still, okay? It is not moving. So like a building, industry, factory, things like that. Mobile are things that move, trains, planes, cars, okay, trucks, all of those would be mobile. And so things that are currently producing pollutants, whether they're stationary or mobile, it has regulatory controls for the disposal of items that could lead to air pollutants or air pollution, okay? So a really good example of that would be old refrigerators used a chemical called chlorofluorocarbons, lots of different types of CFCs, chlorofluorocarbons, in order to keep our food cold. Well, we found out later that CFCs actually eat a hole in the atmosphere in the ozone. And that's really bad. We need the ozone to protect us from the sun. And so as soon as we figured out that that was related to CFCs, we stopped using that in our refrigerators. But some of those refrigerators are still out there. And if you ever need to throw one of those away, there's specific disposal guidelines that you have to follow. Emission of pollutants that harm human health, environmental health, and atmospheric health. Okay, so environmental health would be more like water, ground, things like that. Atmospheric would be the air, all the way up to the ozone layer. Okay, so atmospheric health is the planet as a whole, right? So anything that is harmful to humans or the environment or the planet are going to be controlled for in this act. Many chemicals are regulated, including, we'll do a few on a list here, carbon monoxide, CO, VOCs, that stands for volatile organic compounds, and we're going to learn more about these in a coming assignment. Nitrogen oxides, which we sometimes abbreviate NOx. CFCs, so that's what I was just talking about in the refrigerators, chlorofluorocarbons. CH4 is methane. SO2 is sulfur dioxide. And ground level ozone. Okay, so that's a short list of chemicals. There are others, I'm sure, but those are major ones that we're going to be talking about in our class. And they are controlled by this law. Okay, so releasing them at large quantities isn't just allowed. You can't just make these and put them out into the air. There's controls. Okay, I want to talk about benefits of the act. Okay, benefits of the act. So this has been around again since 1963. So we've got lots of benefits that are floating around here. 184,000 deaths per year have been avoided. Okay, so people have died of lung problems because of toxic air, and they still do every year. People die from complications from breathing unclean air, okay? But 184,000 deaths per year have been avoided due to changes that have been made because of this law. 674 bronchitis cases per year avoided. 22 million work days saved. So we're talking about people don't go to work when they're sick. And so when we have people getting less sick because their air is cleaner, then we save those work days. So 22 million work days have been saved since the act was created. $20 trillion, I already wrote dollars, $20 trillion saved in healthcare costs. $20 trillion saved in healthcare costs. And then we get to some cool percentages. 40% reduction in SO2. So there's 40% less SO2 in our air now than there was before this act. 30% reduction in NOx, so nitrogen oxides. 50% reduction in CO, carbon monoxide, which is super toxic. So we have 50% less carbon monoxide in our air now. 45% reduction in solid particles released into the air. Okay, so those are called aerosols. Aerosols is going to be a word that we talk about that I really want you to know for the test too. So if you need to highlight that, mark it somehow, make it stand out in your notes. But it's a 45% reduction in solid particles released into the air. So aerosols. A good example of an aerosol is if you ever see a diesel truck accelerate in a certain way out of a light. Sometimes we call it like rolling coal, okay? That releases a big black cloud of smoke. The black cloud of smoke has a lot of stuff in it, but the parts that we can see, that the soot that's in there, it's actually primarily carbon, but those are aerosols and they're very not good for our lungs. Those particles can get into your lungs and stay there for decades, okay? They can also get into your bloodstream via your lungs. So aerosols are not good. They widely range in what they're made out of, but that is one thing that has dramatically been reduced since the Clean Air Act was enacted, okay? So that is the end of the notes for the U.S. Clean Air Act, and we will continue with more air chemistry in the coming assignments. Thanks.